Okay, so the next thing that I'm going to be covering is going to LINQ method syntax. The previous syntax that we used was LINQ query syntax, and they kind of tried to mimic what looks like SQL code in a C# code, and I think that was kind of neat at the time because developers kind of felt comfortable with what it looks like and what it does, but it's not the same, and it's actually becomes kind of weird. So this, we said, compiles into the different syntax in the background, so people started using something called method syntax, and that uses LINQ. That uses lambda expressions. So LINQ operators using the extension methods came in .NET 3.5 as they were added as extension methods to a enumerable class. So a enumerable class was added these extension methods in .NET 3.5, which is kind of important and kind of a little bit of a breakthrough. So anytime when you take the enumerable, when you implement it, and that's quite a bit in .NET, you also have these extension methods that can be used to massage this data that is inside of the object that's using this enumerable class. Most of the time some kind of a list. So there are 50 or so of these extension methods. So the extension methods extend any type that implements, like I said, enumerable interface. So to say it in a common language is that anything that we can iterate through that can use the for each also has these extension methods. So we can use these methods with anything that has we can use a for each or for each loop. So the first one of these methods is going to be first. So first, we can get a specific item in the list that matches the criteria that we provide. If the item is not found, however, we get an exception because it can't handle the null. So let's see how this works. So here's our query syntax. We can go ahead and get rid of that. And now we're going to go ahead and rewrite this using a method syntax. So first thing that we need to do here is we need to grab a list, which is customers. And then we can go ahead and use our extension method first. So we want to get it first. And this would actually get the first item from the list. We don't have to put anything in there, any criteria. But we actually want to get not a first item in the list. We want to get the one that customer ID matches the customer ID from the list. So in order to do that, we need to go ahead and pass our customer object into this list, individual one. So now we are passing the individual customer object into the list, and we are saying where customer ID inside of this object is equals to the customer ID that we are passing. So this will actually select the item that matches the customer ID that it passed, and it will return that particular object. Let's try to build, and it looks like everything is building. So that means that all the types here, if you're returning, are correct. We're returning the one individual object. So first we'll always return that's also important to remember. It will return the type, type. It will, the compiler will automatically know which type. So I can put a customer here, so it will know it's the customer. So let's go to our tests now. So this test should still be running exactly the same, because we're basically doing exactly the same thing here. We're just getting the customer with the customer ID is 2 that we passed, and in test, like you can see, it's 2 Biggs Bilbo. So if you run a test, see that passed. But the problem arises here is if we pass an ID here that doesn't exist. The first method doesn't have ability to handle if something is not found. So it will break. It just doesn't know what to do. Nothing is found. It's like, oh crap, I don't know what to do, and it's just breaking. So in order to be able to return null if something is not found, we use a first or default. So now if we return a null, it's not going to break. So that's how we use first or default. It basically selects one individual item or object, and only one from our list. First will not return null if nothing is found. First or default will return a null. Using where is the next one that we'll work on, and where actually can return multiple entries, not just one. So for example, here we have a list of 1, 2, 3, 4. We are filtering where items in the list are greater than 2, and that'll be 3, 4, and 5. So it will return the list of items that matches the criteria. So here I'm trying to use where, and like I can see here that this can't happen because where returns the list of items, and I'm trying to put this in a customer. I can go ahead and change this to var. Now it works because it automatically casts this to comply, understands that you're trying to return I enumerable of a customer, but our method is also just a customer. We can change this to object, any object, and now we see that this will actually work. But to test this, we're going to need to green out these, comment out our 2 test methods, and then I have a test method that I use to check that the value that is coming back is this one. But then another really curious thing that I realized here is if we are returning the list and we're using an object, we can't really call it doesn't have the way to call each item on it. It's almost like it's not a type safe. Well, it's not type safe, so that's the problem with using this. So what I would really have to do here is I would have to make it type safe, so I have to turn this to IEnumerable of customer. I will have to match the type. Now our result here should match. So here, since I'm returning this is actually the IEnumerable, it's a list. In order to get these values out, I have to get each one from it. So I have to use for each in order to test. And I'm asserting this right here. And I'm asserting each one, customer ID, last name, first name, matches for Cotton and Rosie, and that's what I should be getting. So let me try to run this test and see if it passes. And it's not passing. And let me see what's going on. So after quite a bit of work here trying to test these two collections, I was unable to compare, even though the lists are identical. It's because it's a reference type, and it's very hard to compare the two if they're not the same in the memory. I guess it's just very tough to compare two lists. Unless it's exactly the same list copied twice. So instead I went ahead and I just looped through the first one and just used this index, since I know that I'm returning only 2. So it's 0 comparing the last name, and I do first comparing the last name to the one that we're returning. So here, to go back here is and I also changed this to list, and it became very similar to the list that we had. I'm going to change it back to IEnumerable, which kind of made me understand a little more why we were returning to list, because this is not IEnumerable is not exactly the same as the list. Sometimes we need the list more. You see, now that I change it to IEnumerable, this is failing because it's not a list. I can't traverse through. I wonder if I can add this to list here. And it's still nothing. So here I had to switch it back this to list, or otherwise that just doesn't work. And returning list, so this has to match. And then I'm able to use for each here to go through the list. And when I run the test, it passes. And that's how this is one of the first example is using the where, and I had to use to list here in order to test it. And then we could also try to, although we're using where to filter through, which wouldn't really make much sense, but this is how she explained how to use the skip. So basically we would change this back to just to be a customer. Skip 1 and then first or default, or otherwise if it's not first or default it wouldn't return our customer class here. So without this, I don't think it will compile. See? So we need first or default for this to actually return our single customer object. So now we are skipping one, getting the first or default, and this will return our second customer, which this is not going to be compiling anymore because now we changed the type there. But since I'm getting the second customer from the list, I can just assert the actual class last name, compare it to cotton, run it, and this test will pass. So this was a good exercise to see a little bit how collections work, how they're tested, why we need a first to default when you're selecting an individual one, why we need to list if you want to return a list that we can do something with, and just kind of you know, what type of types are we using. Skip, we can skip through to certain parts. For example, if we need certain element in the list, we use skip. You know, thinking about power of this that I have, knowledge that I have here, using skip 1, skip 2, skip 3. I don't know if this could also be somehow used when we're trying to add each. For example, if we have a list of items, integers, then we want to add first one to all of the items, then a second one, then a third one. Then we could skip and put some kind of counter, well, +1, +2, plus, you know. So that's LINQ where skip first or default first.